All right, so what we're doing now are called trig identities. And trig identities are kind of like little trigonometric proofs. Okay, some of them are not so little, some of them are complicated. But use these basic identities to do things called establishing an identity, to show that the left side of an equation is equal to the right side of the equation. Okay, so here we already have gone over several of these. This is tangent is equal to sine over cosine, cotangent is equal to cosine over sine. We learned this in the last chapter. Okay, cosecant 1 over sine, secant 1 over cosine, cotangent is 1 over tangent, and the reciprocal of that is also true. So for example, we know that sine is equal to what? Sine of theta is 1 over what? Cosecant theta, and so forth. And cosine of theta is equal to 1 over cosine theta, and so forth. Okay? So, whoops, 1 over secant, I'm sorry. 1 over secant theta. And tangent theta is 1 over tangent theta. Okay? 1 over secant theta. So now, these are called the Pythagorean identities. Okay? And it said sine squared plus cosine squared equals 1. And 1 plus tan. So this one's comes out of the unit circle. And that's just using the idea that this squared plus this squared equals this squared. These things also come out of the unit circle. Okay? So you should remember these have 1 plus tan squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. And these could also be written in various forms. So I could write this as sine as 1. This one comes up a lot. 1 minus sine squared, you could move these around, equals cosine squared. You get that? All I did is I subtracted sine squared from both sides. And I could write like secant squared minus 1 equals tan squared. So I could write those in various forms. Or what were you going to say?
Tangent squared minus secant squared equals -1.
Very good. Tangent squared. So you could move these around, into various forms equals -1. So let's subtract.
First term being minus 1 plus sine.
1 minus sine squared equals cosine squared. And 1 minus cosine squared, likewise, equals sine squared. So these are things that come up quite a bit. If you said sine squared minus cosine squared equals 1, would that be correct? No, that would be a case of mistaken identities. That's a joke. A case of mistaken identity. These are called identities. All right, so I made a joke there. Okay. So anyway, that was planned, I know. So these are called the even odd identities, where it says that sine of negative theta can be written as negative sine of positive theta. Cosine negative theta is equal to cosine of positive theta. Tangent is odd. Cosecant is odd, meaning I can take that negative side and pull it out here. Secant, like cosine, is even, meaning the secant of a negative angle is the same as the secant of that positive angle. And cotangent is odd as well. Okay? So how does all this work? So say I want to establish an identity like right here. What I can do is, usually what you want to do, or in many cases, is to rewrite things in terms of sines and cosines. Okay? And that will help you establish the identities. How could I rewrite cosecant of theta? 1 over sine of theta. And you can only, the rule with identities, you're only allowed to work with one side. So you can't change both sides at the same time to try to make them meet to be the same thing. You can only work with one side at a time. And usually work with the more complicated side and try to get it into the simpler side. So how can I rewrite tangent of theta? Sine of theta over cosine of theta. Right? And that gives you, this cancels out. And what's 1 over cosine theta equal to?
The secant of theta.
That's equal to secant of theta. So I have just shown that this side is equal to the secant of theta. And so they're like little proofs. You're trying to prove usually that the left side is equal to the right side. Sometimes that the right side is equal to the left side. All right? So let's go on to another one. All right? And there's different techniques that you need to solve it. This one's pretty easy. What do you think I could do with that one? Other than hammering. What could I do here? What? Well, yeah, you could use the even odd thing. Okay, so this can be written sine squared of negative theta just means the same as sine of negative theta quantity, that thing squared. That's what that means. This is just kind of a shorthand to write that. Plus, I can rewrite this as cosine of negative theta squared. And you want to show that that's equal to 1. Well, I already know that sine of theta, because of even and odd properties, can be written as negative sine of theta squared, right? Plus, how could I rewrite this? Cosine of positive theta squared. And sine, when I square something, it turns it, when I square a negative, it turns it into a positive. So I get that sine squared of theta plus cosine squared of theta. And you're trying to show that this is equal to 1, right? Is this equal to 1? That's an identity. That's your first Pythagorean identity. So that thing is equal to 1, so you get that. We get to say like this equals 1, right? And so 1 equals 1, so that's what I kind of keep the right side here as I go. I want to keep this piece, keep bringing it down and show that. So that's right. Okay?
Yeah.
That's easy. They get harder though. Don't worry.
Why do they get harder?
Why do they get harder? Because, I don't know, they just do. Okay? So in this one, yes sir.
The cos shouldn't have been negative in that second step.
Shouldn't have been negative in the second step. What do you mean? Where?
Look at the odd even.
Here? This?
The cosine.
The cosine? No, because cosine's an even function, right? So cosine negative theta is the same as cosine of positive theta, right? Going back here to the, going back there to that original identity. See right here? It says cosine of a negative theta is equal to the cosine of a positive. Okay? We got it. Let's try to do this. So establish the identity. So again, you probably want to work with the left side because it's the more complicated side. And so what I'm going to do is, can you just cross those out? No, you can't cross those out. Why not? For the same reason I can't take 3 squared plus 4 squared and have a 3 plus 4 on the bottom and go like this and then say that that's equal to 3 plus 4. It's not, is it? Right? I can't do that. Okay? You can only cross things out if it's, uh-oh, I need a bigger eraser. You can only cross things out if, is this an eraser? That's an eraser. Ooh, look at that big eraser. Ooh, that's wow. That's cool. All right. So what I want to do here is rewrite this as negative sine of theta. I'm kind of skipping a step here. Squared minus cosine of theta squared on the top. Okay? And on the bottom, I'm still going to have my negative sine of theta minus cosine of theta. You guys see what I did? Hello? Okay. So this is, what is this? I got to think a minute. I got it. So when I square this, what do I get? I get sine squared theta So I get sine squared, I'm going to write it as sine squared theta, minus cosine squared theta. And I'm going to write this on the bottom. I don't like having a negative sign in front because I'm going to do something here. Cosine theta, no, I'm going to leave it, okay? What am I going to do? This is what I'm going to do. I'm going to pull out a 1, and I'm going to get a sine theta, a negative 1, plus cosine theta. Why on earth would I want to do that? Because this is like having x squared minus y squared. Right? This and this. Anyone know how that factors? You should. X plus y times x minus y. Right? You know that that's equal to that? So what I could do with this is I'm going to rewrite the top as sine of theta minus or plus cosine theta times sine of theta minus cosine theta, and that whole thing over this, negative 1 times sine of theta plus cosine theta. Now what could I do? Now I could cross something out. What could I cross out? This and this are the same, so I could get rid of it. Right? And when I divide that by negative 1, this turns into negative, which is what I have up here. And this, a negative divided by a negative, is equal. So let me just one step at a time, okay? So now I have sine theta minus cosine theta divided by negative 1. And if I divide this by negative 1 and this by negative 1, I get that's equal to cosine theta minus sine theta. And then I'm done because that's what I'm trying to show, that it's equal to 3 cosine theta minus sine theta. And you could say, how the heck would I know how to do that? And I would say you got to practice and you got to do lots of problems and you get the hang of it after a while. Okay? So, and there's different ways to get from here to here. Okay? But you have to show your steps. So first what I did is I squared it, then I factored it. So a lot of times you're going to try to factor things to get things to work.
So we're basically using like a lot of these properties.
Yeah, you're using a lot of those properties to show that one side is equal. They're fun. They're like little puzzles, right? So, we got more. We're going to keep going. I'm going to get through these 3. Okay? So this one here, establish the identity. You say, I don't know how the heck to do that. Anyone have an idea? Okay. One thing you can do is, let me think about this one. One technique you can use is find a common denominator. So I'm going to find a common denominator, and to do that in this one, I'm going to multiply this by sine of theta over sine of theta. And this fraction, I'm going to multiply by what? 1 plus cosine theta over 1 plus cosine theta. And let me show you what that results in. Right? When I multiply this by sine of theta, I get sine squared theta, right? Sine of theta times sine of theta makes sine squared theta. Plus, then I'm going to FOIL this 1 plus cosine theta with 1 plus cosine theta. And when I do that, I get 1 plus cosine theta times 1, and cosine theta times 1 makes 2 cosine theta. Plus what? Cosine squared theta. So this is like 1 plus x times 1 plus x, right? That's basically what I'm doing over here. This times this. So it's 1 times 1, x times 1, and x times 1. That's where the 2 cosine theta comes from. And x times x makes x squared. See that? So now, on the bottom, I have my common denominator, which is now 1 plus cosine theta times sine of theta. That's my common denominator. Because I multiplied this by sine of theta over sine of theta, and this by 1 plus cosine. So now I have an identity that tells me what sine squared theta plus cosine squared theta is equal to. What's that equal to? What's this and this when I add them together? 1. So now what I have is 1 plus 1 plus 2 cosine theta on the top. So in other words, on the top, I have 2 plus 2 cosine theta. And on the bottom, I'm going to leave this as it is, 1 plus cosine theta over times sine of theta. Does anyone see something that I could do? What could I pull out of both of these? 2. So I have 2 times 1 plus cosine theta. I know I'm going fast.
What do you get? 2 cosine theta.
This 2 cosine theta?
Yeah.
Cosine theta times 1 plus cosine theta times 1 is 2 cosine. 2 plus? Because sine squared plus cosine squared equals 1, right? So 1 plus 1 equals 2. And then I'm pulling out this 2. And now on the bottom I have a 1 plus cosine theta times a sine of theta. And what can I do with these 2? Now I can cross them out. You can only cancel things when they're being multiplied, right? So I have that this is equal to 2 over sine theta. And how can I write 2 over sine of theta? Remember what I'm looking for. 2, I can rewrite that as 2 cosecant theta, because sine is a reciprocal of cosecant. And then I've set out to where I'm trying to get to. See? Wowza. So these are harder ones. Tonight's homework, you're not going to have the hardest ones. Okay, you're going to have some easier ones. So we're going to keep going. I'm going to do one more. We'll save the next one for tomorrow. Okay. Whoa. How is this mess equal to 1? That was pretty complicated, doesn't it? Do you think you can make this mess equal to 1?
Yeah.
We're going to make this mess equal to 1. Anyone have any ideas?
Change tan and cosine.
Very good. Change everything to sines and cosines. Okay? I think that's going to work. Let's see. Sine of theta over cosine theta plus cosine theta over sine of theta. And a lot of times you'll get these ugly looking double fractions. 1 over cosine theta plus 1 over sine theta. You guys see what I did?
Why are you doing that?
So it's sometimes changing everything into signs. Oh, it's times. You're right. Okay? So now what I'm going to do is I'm going to find a common denominator for this top fraction. Okay? So what I'm going to do, I'm going to multiply this top fraction by, what am I going to multiply this by? Sine of theta over sine of theta. And what am I going to multiply this by? Cosine theta over cosine theta. And then, so what I now have is sine times sine makes sine squared theta plus cosine squared theta over sine theta cosine theta. Ah, almost done, right? Cosine theta over 1 over, this is the same as 1 over sine theta cosine theta. That's not a square, that's a theta. So now what can I do? What can I do with that and that? I can multiply by the reciprocal, which will make this and this cancel out. Okay? So now I am allowed to do this just in case algebraically you don't know this. You're allowed, if that's the same as that, you can cancel those out. And what I'm left with is sine squared plus cosine squared over 1, which is just sine squared theta plus cosine squared theta. And what's sine squared theta plus cosine squared theta equal to? 1. So that's where I'm trying to get to. So I'm done. See? That's a little tricky. Yes, sir.
You go over the canceling.
Yeah, this?
Yeah.
Okay, so if I have a fraction like 1/2 over 3/2, right? That's the same as 1/2 times 2/3. Remember that? So I can cancel that. I did, so that's equal to 1/3. So I just kind of took a shortcut. I said, I know that if you have every other one, you can cancel those out. So this is equal to 1/3. See? So that's basically what I did here. I have this and this. So if I multiply by the reciprocal, this thing and this thing would cancel out. Here, no, that's just sine, that's a time. Yeah, I'm sorry. That's kind of misleading, because this is time. All right, and we're going to be done. And you could